Welcome to the Deep Dive. Today we're heading out, way out, about 12 million light years to the constellation Centaurus.
And we're looking at a specific spiral galaxy, NGC 4945. Looks fairly normal from a distance, right?
Yeah, it looks like a typical spiral, but it's hiding something pretty intense, isn't that?
Yeah.
A supermassive black hole that's, well, acting up.
I was putting it mildly.
Is
It's
it?
got this ferocious secret, as you say. We usually think of black holes as just consumers pulling everything in.
Right, like a cosmic vacuum cleaner.
Exactly. But this one, it's not just eating, it's violently expelling matter, too. It's quite the paradox.
And I know this how. There's some new research.
Yes, based on really detailed observations. We're talking data from ESO's Very Large Telescope, the VLT, specifically using an instrument called MUSE.
MUSE. Okay, I've heard of that. It's good at mapping things out, velocities and such.
Precisely. It can dissect the light incredibly well. And there are wider shots, too, from the MPG ESO telescope at La Silla. It all came together in a Nature Astronomy paper back in March.
Got it. So our mission for this deep dive is to unpack what's going on with this black hole. How different is it really? Let's maybe start with the baseline. What's like normal supermassive black hole behavior?
Well, normal is relative, but typically they are these huge gravitational centers. Think of the one in our own galaxy, Sagittarius A. It pulls in gas and dust, sure.
But it's relatively calm about it, more of a steady trickle.
Yeah, kind of a slow feed compared to what we're seeing in NGC 4945. This one is consuming matter at a much higher rate. It's really gorging itself.
Okay, so intense feeding.
Yeah.
But you mentioned expelling matter too. That's the weird part.
That's the really fascinating part. The MUSE instrument detected these incredibly powerful winds, cone-shaped outflows of gas and dust blasting away from the center.
Cone-shaped. So directed blasts. In the images, they show up highlighted in red, right? Looks dramatic.
Very dramatic. And these aren't gentle breezes. We're talking about material moving at hundreds of kilometers per second. So fast, in fact.
Fast enough to escape. Like, leave the galaxy entirely.
That's the current thinking, yes. These winds are so energetic, they're expected to overcome the galaxy's gravity and just drift off into intergalactic space.
Wow. Blown right out of town. But hang on, there was something else in the findings, something even more surprising about these winds.
Ah, yes. And this is where it gets really counterintuitive. You'd expect something blasted outwards to slow down, right?
Yeah.
Gravity pulling it back.
Sure, makes sense, like throwing a ball up, it slows down.
Exactly. But the MUSE data shows these winds accelerate as they move further out from the galactic center. They actually speed up.
They speed up. How?
Well, that's the million-dollar question. The precise mechanism driving this acceleration is still under investigation. It's a real puzzle, but the observation itself is solid.
Okay, accelerating galactic winds, that's wild. What does this all mean then? What are the bigger implications?
There are a couple of big ones. First, think about what's being thrown out. Gas and dust. That's the raw material for making new stars.
Right, star fuel.
So, if the black hole is ejecting this fuel at high speed, especially accelerating speed, it could be actively preventing new stars from forming in certain regions. It's like the black hole is regulating the galaxy's star birth rate.
A galactic thermostat controlled by the central black hole. Interesting.
Sort of, yeah. And second, consider the black hole itself. It needs that gas and dust to grow, right? That's its food. But if it's blasting away its own fuel supply with these powerful winds, well, it might be limiting its own growth. It's a potential self-regulation mechanism.
So it prevents itself from getting too big by essentially pushing the dinner plate away.
That's one way to think about it. It points towards this complex interplay, maybe even a kind of equilibrium between a supermassive black hole and its host galaxy.
Checks and balances on a cosmic scale. So these findings for NGC 4945 aren't just a one-off curiosity. They tell us something broader.
Absolutely. Understanding these kinds of black hole-driven outflows, especially accelerating ones, is crucial for modeling how galaxies evolve over billions of years, how they get their shapes, their star content, everything. It reshapes our picture of galaxy evolution.
And the MUSE instrument was really key to seeing this acceleration specifically.
Definitely. Its ability to map velocities across the outflow was critical to uncovering that surprising detail.
Okay, so to wrap up, the big takeaway is this black hole in NGC 4945 isn't just sitting there. It's actively sculpting its galaxy through these powerful and unexpectedly accelerating outflows.
That's the core message. It's a dynamic, almost symbiotic relationship, but a very violent one in this case.
It really changes how you might think about black holes, doesn't it? Not just destroyers, but maybe shapers too.
It certainly does. And maybe that's the final thought for you listening. How does knowing this shift your perspective on the role these cosmic giants play? And what could the long-term consequences of these galaxy-scale winds possibly be for the wider universe? Something to ponder.